Okay, thank you everyone for attending and for the invitation. It's great to be here today. Um, so I'm going to start by talking about generative AI for health economic evaluation in general, and then look a little bit about some work we've been working on in building software and tools to help review models. So I guess the first thing to say is that there's very limited peer-reviewed literature out there on generative AI for health economics. There's some kind of early papers that are essentially looking at, what are the opportunities, what are the challenges, what are the policy considerations around this. And there's a really nice paper by Florence et al. That I'd recommend having a look at. Kind of gives an idea of the landscape, where things are, and some kind of signposts to some early works. Um, Looking more specifically at actual published papers and methods, there's a nice paper by Reason et al. 2024 for some work done with BMS, looking at using AI, so generative AI, to automate some health economic models in the R programming language. And they provide a case study of how that's done, and I'll talk a little bit about that later. I'm sure we'll go to questions about those kind of methods. And then what I'll kind of discuss a bit today and talk about a bit today for those that are from a health economics background is an R package that we've been working on to help improve quality assurance of models. So from a teaching perspective, this might be useful for those that are trying to kind of learn to understand a model that's been provided to them, say a teaching model or a model that they're reviewing for some reason. But it would also be useful when building your own model to try and understand how your model could fit together correctly and to do quality assurance as you're building your model. And so we've written a paper on that package as well, which is currently in kind of in press, but we've got a preprint that's ready for download, and I can share the link after the presentation. So in terms of the background and motivation for this piece of work, so generally speaking, when we're kind of asking somebody to review a model, or even when we come back to our model after say 6 months, um, the conversation might look a bit like this, and somebody would say, can you help review this, or can you review this piece of work, or you'll get asked by your line manager or your boss to review some work, and you'll open it up, and it will be something like this, and it will just be a lot of code, and even a very well constructed model is still going to be a huge amount of code to kind of debug and try and understand how that all fits together. And so then you might feel a little bit like this. And that's often the experience of people reviewing the models or coming back to models later on, whether that be in Excel or R or Python or whatever programming language you're using. It's very kind of difficult to understand how they fit together. And so we developed this R package called Assert HE, with the idea being that we'd provide a set of tools that made it easier to verify models and validate models that had been created, and also to check as you are developing a model to check that you're constructing it correctly and haven't got any obvious kind of bugs and errors within the model. And so what this outputs is a visual representation of a network of algorithms. So for those that aren't health economic modelers, the models that get constructed will typically be a series of equations and algorithms that are either nested or sequential. And so you might have one calculation that's being done that calculates the costs associated with some treatment, or defines transitions between different health states, or calculates health state utility. And those different equations and calculations will be done kind of sequentially, but also will be nested inside one another. So you can end up with some quite complicated networks of algorithms. And so trying to understand how that all fits together is very complicated. And so when we open up a model and look at a model, we want to know, has this model been tested in a coherent way? Does it make sense? Can I understand how this model has been constructed, and how this problem has been kind of conceptualized? And so having a visual representation of that can be really useful. So what's up on the screen is an incredibly simple teaching model that we used as a kind of case study to help build the software. But I'll go through later some kind of production-ready models that have been used by NICE, for example. And so what can you see? So when you click on one of these nodes, you can then see the name of the algorithm or the function, where that function is located within the code base, and where any corresponding tests are located, and also the code coverage associated with those tests. So if someone's written some very well constructed code, then you might expect that they have tests of that code to ensure that that runs correctly, and coverage might be really high. Whereas if they've not written any tests on that code to make sure that it's doing what they'd anticipate, then you might get very low or no coverage. So what we've done is color in anything with above 80% coverage green, and anything with below 20% coverage red, and yellow between those two figures. A nice thing about the tool is that as you're starting to conceptualize your model, you can add in your own functions within the tool and kind of show where they would sit. And so we can see this being particularly useful for teaching in a kind of education setting, but also for teaching junior colleagues when building models, because you can, rather than just say, okay, so we want to build in or adapt this algorithm to do X, Y, and Z, you can click and show how these different functions that you're proposing would all fit together given the current modeling structure. And this is all completely interactive and can be saved and sent to other people. So then the kind of so far has essentially been a kind of an exercise in computer science and network analysis of algorithms that are constructed in a programming language. The kind of AI or generative AI bit of this is in once we've broken down this problem. So you have a model and you're trying to understand how that model works. Once we've broken down the problem into lots of small functions and algorithms, we can then pass those to a large language model and get them to summarize each function. So if we were to try and do that for the entire model, we'd be passing through way too much code, way too much information, way too much complexity to the model, or to the large language model, and it wouldn't be able to cope. So if we just gave it an entire R model with 2,000, 3,000 lines of code and pass that through to a large language model, it would really struggle. But if we pass through a single function with 20 lines of code, large language models are surprisingly good at summarizing and providing a kind of clear layperson representation of what that function is doing. So that's what we go about doing. So within this tool, essentially we allow you to click on any of the functions from the model and click this robot button, which generates a large language model summary of what that function is doing. And so what that does is extracts data about that function from the documentation. So it takes the arguments that pass to the function, the body of the function, and the outputs, and it stores all that information as data. It then creates a prompt and feeds that data into a template that we pre-created, essentially to say, we want you to act as a reviewer and provide a summary of this function, and then the data is inserted into this template prompt, and that prompt is sent to a GPT. So for those of you who are familiar with ChatGPT, will be familiar with interacting with a large language model. You type in some text and the large language model responds. Now that's great if you're a human, but obviously if you want to interact with this from a machine as a computer, you generally want to be working with what's called APIs, and essentially that allows your machine to send the same types of queries that you might type to the large language model online. And so now we have a user interface that allows the user to click and to send this request to the API from OpenAI and get back a summary. So you could achieve a very similar thing by copying and pasting, going into the documentation for the function, copying and pasting all the right bits, pasting that into Word, getting a really nice prompt, and then pasting that into ChatGPT would give you a similar result But here, obviously, it's just one click. It's much simpler when you're trying to navigate a model. And so we then receive the response, reformat the text, and then show that text in the modal. So this is what that ends up looking like. So say we'd clicked on the create Markov trace function. We weren't quite sure what that function does, why that's there. We can then click on it. It sends the request to the API with the prompt pre-created, and then returns you 2 paragraphs about what that function does. And so we've tested this with a few different case studies. So this is a CDX2CEA model, so biomarker testing, cost effectiveness model that was built by colleagues from Stanford. And we've tested it on that model. It seemed to work fine. So we get this network and we can play around and understand how the different functions fit together and generate this AI summary for a function. We've also tested it on the University of Sheffield diabetes model. Again, that allowed us to understand how that network of functions fit together, much bigger model. And the nice renal cell carcinoma model, which is absolutely enormous. And so having the ability to see how that model fit together was really useful for those that were working on it and adapting it, and being able to summarize any of the functions. Again, really useful. I can actually show what this looks like. So I took a short video of what this was. So you can see here, we can go to any of the functions. We can zoom in. We can click on that function. We can click for a review. We wait, it sends off the request, and then we get our summary for that function, which is obviously useful for someone who's completely new to the model. So in terms of next steps, this software is completely open source, so you can see it at the link below on the bottom of the slide there. We're looking at testing the software in as many models as we can. So I think we're up to about 10 to 12 models now. And people have been very kind in testing it on internal models, so things that are not even open source, and suggest improvements. So some people have submitted pull requests to GitHub, which is great. And we're keen to expand the testing functionality. One of the things that we're looking at doing is taking our teaching materials. So we as a company and as an organization run a lot of training on the use of R for building health economic models. That's a big part of what we do. And so we have a huge amount of training content. So we're trying to work through retrieval-based methods to try and kind of augment those prompts to improve them. Yeah, so there'll be a publication shortly on this topic, and we'll be able to disseminate that when we can. But there is a preprint available at the link in the slides. Yeah, so I suppose that's just a sort of narrowed down very quickly into a general focus on reviewing models. But of course, there's a much kind of broader perspective around the use of these large language models and generative AI in general on health economics. And so my experience sort of overall is that generally generative AI is much, much better at summarizing, so dumbing down, than really kind of novel problem solving. So if you were to take something that's very complicated and ask for it to explain it in a kind of simpler way, it's very, very good at that. Very good at, for example, editing very complex scientific papers and describing them in the language of, say, a 10-year-old. It's incredibly good at that. Coming up with a novel solution to a problem, it's not quite so good. They will make things up with confidence. So the task of the reviewer and the human is still very much needs to be in the loop at the moment. In the future, we don't know, but at the moment, you get a lot of hallucinations and things that unfortunately you have to kind of be an expert to know that they're wrong, which is very dangerous. Volume matters a lot, so they're very, very good at small tasks. So it's kind of like having a large number of grad students who are quite good at one small thing. So they can't put the whole task together often. And there's an increasing role in recent publications on kind of essentially stitching together prompts to achieve a broader task, but that still requires a lot of human interaction. So just asking generative AI, large language model, can you build my model at the moment is not feasible from the outset. Um, it just struggles with the nuance of complex series of tasks that are kind of sequential and nested. But it's very, very good at doing small tasks. So it's kind of splitting problems down into very small tasks and then assigning them um, to AI systems. Um, Carefully written prompts are crucial. So obviously, if you provide it with garbage, then you get garbage back. And the kind of earliest use case that we've been seeing, and I think pretty much everybody's been experiencing to some degree, is just this replacement for human sort of Googling and looking stuff up on Stack Overflow. I think very huge numbers of people are working with things like ChatGPT on a daily basis to the extent that we're kind of already using it within our systems. It's just that it's a human who's taking the code from ChatGPT and copy pasting it back into Visual Studio or RStudio or whatever you're working with. So there's probably a next step to kind of gradually reduce the role of the human in that interaction. That being said, there's a huge amount of potential. So we are looking at much more efficient model builds. So rather than spending, a week having to code something up, being kind of augmented, human augmentation with GPTs might speed that up to take a day, which then frees up a lot more time for focusing on more interesting things. So methods development, really understanding and conceptualizing the problem, which is a kind of a huge thing if we're wasting a lot of time focusing on the code and on the model build rather than actually thinking about the big picture. Like why are we building this model in this way? What are the real kind of drivers for stakeholders? That kind of things. And there's a lot of roles with a big role that it could have for doing things like double coding, reviewing, trying to identify bugs and errors. So there's a few papers published recently highlighting the sheer number of errors that we've seen in recent years in health economic models. So I think having a large role in even just identifying those errors for commissioning decisions worth millions of pounds would be good. And then hopefully having some role in making these models more transparent. So the example that I've given on with our work is obviously being able to summarize these functions that for a layperson, so for a person who's not well versed in programming, they would never be able to understand what that function is doing. And so having an interface like this where someone who's not necessarily a health economist or a programmer can look and understand how the model fits together and see that is much more transparent. And finally, I think freeing up the time again should lead to a bit more cross-pollination of ideas with other disciplines. And we might see this with if the amount of time it takes to really understand a topic reduce significantly, we might get a lot more ideas from other areas kind of feed into health economics and health economic evaluation. And that's probably one for another whole another talk. There are quite a few challenges though. So there's a danger for open source in general. So if nobody really gets any attribution for their work because essentially things are getting kind of fed into large language models and then reported back by the large language model, where is the incentive for thought leadership and for publishing? So currently, you might use some method, some algorithm that somebody's created and attribute them. And as much as we would like to say we go to work for the benefit of humanity, there's a certain amount of ego and career progression that goes with that. And so if we're using these large language models and they are just giving us the answers, but based upon published open source code and literature, but with no attribution, then where's the incentive to come up with novel new ideas and to publish them? So there's a bit of a danger there. Obviously, there's the hallucinations and making things up with confidence issue that a lot of people have talked about. There's also another issue of, simple tasks like reviewing functions or writing specific small bits of code are done by Gen AI. How do people learn and develop? So at the moment, it's kind of fine because we've got some experienced programmers who can use generative AI to test their work and to kind of speed themselves up. But actually, if nobody's ever learning the initial code base and language, then how do people get to that stage? So when the current 30, 40-year-olds retire, will the generation in 2 generations' time actually really ever get hands-on with the code, or will they just be copy pasting from um, or allowing GitHub Copilot to write things for them. So this could be a real problem. Um, and then finally, how do we keep the human in the loop? And do we really need to keep the human in the loop? So at the moment, there's a danger that we kind of go from essentially a human writing a series of bullet points that creates a model to then another human receiving a model and um, asking an AI system to convert that model into a series of bullet points. And so, is there really ever a human in that loop? Um, and at what stage do we accept that these systems are good enough? And that's probably a theme that we'll keep coming back to. And finally, will we all be out of work? So are we going to all become Luddites because we're concerned about AI? And I'm somewhat optimistic about this and think things will be fine. And there's always been issues in the past and concerns in the past, but I think it will replace a lot of work that currently is probably the least enjoyable parts of our jobs, and hopefully not replace the most enjoyable bits. So we'll see. And finally, just to say, throughout, I've discussed working with R, and this came up at another talk recently about whether um, the use or the development of these tools, so generative AI tools, will cause a shift away from spreadsheet software towards um, programming languages. And my opinion is that it will, because it's just so much better suited for a script-based solution, so for a programming language, um, than trying to feed something into a GPT to then output to an Excel file, which just sounds like an absolute nightmare. It's not something I've done. I've only ever worked with R, um, with generative AI, not Excel, but I think it will kind of cause a shift towards programming languages like R or Python. Um, and so we're kind of trying to prepare for that by making courses available for people so that people can upskill in those programming languages, so that then hopefully we can make more models open source and improve these tools, um, but also so that people kind of understand what's going on. Because if we're developing software and tools to kind of spit out our models from GPTs, then it's really important that lots of people understand what those models are doing and how those models are working. So that's my kind of pitch. And this is my quick comparison to for writing or using a GPT to output an Excel model. It's kind of I was trying to come up with an analogy um, in a discussion the other day, and the best example I could think of was having kind of a humanoid robot drive a horse-drawn carriage. It doesn't make any sense to use something that's incredibly advanced to spit out a bit of spreadsheet output when when the obvious thing is to be kind of having that middle ground of writing a series of functions and outputs in R that the user can really understand. So yeah, that's it from me. I don't know if we've probably got time for questions, hopefully.
So you touched upon a bit about how this could be used in teaching. Can you go into a bit more detail of how you think this might be applicable for people teaching a health economics module?
Yeah, so I guess the main thing is really understanding how the model all fits together. So at the moment, we you think of a series of steps, like the early conceptualization stage. Typically, you'd get taught, and I mean, yeah, correct me if I'm wrong, that you'd want to conceptualize your model, really understand the decision problem. And then there's this step where you're essentially taking a schematic and transferring that over to a mathematical model or a model that's been programmed in some way, either into a spreadsheet or a script. Um, and so what's quite nice is to be able to have a summary back into the conceptual model to say, does this model actually represent this conceptualization? And to be able to see how does this code all fit together. Whereas at the moment, what we essentially do is, for a lot of people, is basically just review the conceptual framework and model, review the parameter inputs, and then just kind of hope that the model is right. Um, and that maybe is a bit dismissive, but I think for a lot of people reviewing models, that is essentially what ends up happening, because it is very, very hard to really go through the nuts and bolts of every line of code or every cell, and it's very laborious and boring. So I think there's a big value add from Gen AI in that space. And that's the same for obviously for teaching, because if rather than saying here's 10,000 lines of code, you can stand up in front of a room of 30 and say, okay, so here's 10,000 lines of code, but actually here's how all of this fits together in a diagrammatic fashion. And here you can click here and then summarize this um, this function or this part of the model and get kind of a layperson summary back, then hopefully that's useful.